Test, test. Yeah. All right. So you guys can hear me. Nice. Hey guys. So this will be the second lecture for ordinary differential equations. So last time uh, we did one master example in correlation to the order of derivatives, and we did in correlation to the order of derivatives and whether it's linear or non-linear. We know that the order of derivative focuses on the highest order derivative, right? So they'll focus on the highest order derivative, meaning if it's a second order derivative, then they will focus on second order derivative. Like for example, this here is a second order derivative because obviously you can see that um, the highest order derivative is 2. Cool. So the highest order derivative is 2. It pretty much makes sense. Okay, I'm going to switch on my lamp. So the highest order derivative is 2. Okay, wait. Sorry about that. So the highest order derivative is 2. And the only way you can say whether something is linear or not is if they don't have this y square or y prime whole square or dy by dx times y or anything that changes y, anything that makes y non-linear, it automatically ends up non-linear. Today we'll be focusing on initial value problem, and again we will do one master example. So this is one master example and we are going to go through every single lecture, like every single step by step as we go along, making it easier for everyone to understand what's going on rather than explaining it and then doing the example again. So we have one equation which is dy by dx is equal to y plus x, where y of 0 is equal to 1. Now we have two equations. We're given not two equations. We're given one derivative equation where dy by dx is y plus x and y of 0 being 1. This indicates that when x is 0, y is 1. Or you can also say this as f of x, right? So this can also be considered as f of x. Now, what happens in initial value problem? I'm not going to explain what is initial value problem. I'm going to write the steps on how you perform the initial value problem. First of all, you look at this equation here. Dy by dx is equal to y plus x. What I'm going to do is write in the format of dy by dx minus y is equal to x. This is what you call a standard linear form. Standard linear form. This means that whatever the derivative equation that is given to you, you're going to make sure that that equation you're going to transform in from a normalized dy by dx equation into an equation in which x represents that. So now, here in this case, x represents dy by dx minus y, right? And the only reason we want to do that is because when I subtract minus y, I get an integrating factor. This is what we call an integrating factor. If I were to write this equation here and avoid writing x is equal to dy by dx minus y, the only time you can write like that is if you're 1000% sure that the way you wrote the standard linear form, the way you wrote the standard linear equation, the way you wrote the standard linear equation, make sure that you are 1000% correct, because writing like this means you're overly confident. So be safe. So this is written in the format dy by dx minus 1y is equal to x. Minus y means minus 1 times y. And this minus 1 ends up as what we call integrating factor. This is what we call an integrating factor. And the only reason we are going to use this as an integrating factor is because we want to make sure that we multiply the entire thing by an exponential, like the exponential of that integrating factor. So generally, you're going to say mu of x is equal to e to the power minus something. Let's say we're going to call it t of dx. So t of dx, and we're going to integrate that, right? So this is how you write an integrating factor. So this is the general integrating factor. We want an integrate, so we want what our main aim is, that we want to get an integrating factor. We're going to get an equation on the left hand side, we're going to get an equation on the right hand side, integrate both the equation, and then finally we're going to get an equation for y. Our main aim is to get an equation for y. However, we cannot just write, because main aim is to get an equation for y, right? Dy by dx minus y is equal to x, then I'm going to say dy by dx minus x is equal to y. Boom, I got y. I'm done. What do I need? I don't have to go through steps. Why do I have to go through steps? I don't have to do that. I got my y wrong. This is what you call a initial value problem. You're trying to get an equation here. When you say dy by dx minus x is equal to y, what you're pursuing is that you got an equation for y, but you have this dy by dx. This dy by dx is not a linear format, or this is not like a general modified equation. You're trying to get an initial value problem. You're trying to get an equation for y, a linear equation for y. You don't want to have any dy by dx. You don't want to have any change in y in regards to change in x. You want to observe y as an equation, not y as, you know, dy by dx minus x. Because if you want to actually plot that in a graph, you will be told to plot that in a graph. You're not going to plot dy by dx. You cannot plot dy by dx. I mean, you can say y is 0. You can't say y is 0 because y here is a dependent value. What is your dy by dx? Your dy by dx here is a change. If you say dy by dx is 1, you're pursuing that your change of that point is 1, not your absolute point. Like if you write y is equal to x plus 3, you're saying x, so x is 0, y is 3, but you're setting x as 0, right? You're setting that x value. X is not change of y in respect to x, or change in t in respect to y. No, no, there's no change here. X is x. But when you say dy by dx is 1, you're per perturbing that the change in y in respect to x is 1. But you're not, in a line graph or any graph, you don't see a change in a y in respect to change in x. That's just typically gradient. Why are you saying gradient is 1, right? So you need to find y, like you need to find an equation of y that can meet for when I plot any value of x, I can find any value of y. So let's just go back. So when I have this dy by dx minus y is equal to x, and then obviously what I'm going to do is this being the integrating factor. So I'm going to write step 2, integrating factor. And so when I look at the integrating factor, I know that mu of x will be e to the power minus integration of t dx. So it's actually integration e to the power integration of t dx. T being some random value, it's not necessary, you can hold any value. T here, we're going to say t is minus 1 here. We're going to say mu of x is equal to e to the power minus 1 dx, which is e to the power minus x. We're not going to write plus c for now, because eventually we are writing plus c in the last line, right? So now what do we know? We know that mu of x is e to the power minus x. Step 3, let's go back to the equation. What was our initial equation? It was dy by dx minus y. So go back to the original modified equation. Know that dy by dx minus y is equal to x. And so now we're going to multiply the entire thing by mu of x. So mu of x dy by dx minus mu of x y is equal to mu of x x. Mu of x is e to the power minus x. E to the power minus x dy by dx minus e to the power minus x y is equal to mu of x x, or x e to the power x. Now, now, what do you see? You have an x e to the power x and you have something else here. When I do that e to the power minus x dy by dx minus e to the power minus xy, what does it tell you? There is some differentiation going on, right? And this differentiation correlates to y e to the power minus x, because if I were to differentiate, so it's just product rule, right? If I differentiate y, leaving out e to the power minus e to the power minus x constant, then I'm going to have d by dx e to the power minus x plus e to the power minus x. So this is just simply referring to, this is written as e to the power minus x dy by dx minus d by dx of e to the power minus x y, which is the same as e to the power minus x dy by dx minus e to the power x y is equal to x e to the power minus x, which then correlates to d by dx of y e to the power minus x is equal to x e to the power minus x. So we got an equation, right? We got an equation. Now we're going to integrate both sides of the equation. So now integrate both sides of the equation. And so now what I'm going to do is I'm going to integrate this guy here d by dx of e to the power y e to the power minus x dx is equal to x e to the power minus x, that will be dx, right? So y e to the power minus x dx, how do you differentiate that? How do you differentiate that? Now we have a dx here, right? We have a dx here. And so now if I say the u and v rule, do you know, remember the u and v rule? If I say that u is equal to x, then du is equal to dx, right? And v would be, so not v, dv would be e to the power minus x, and obviously v would be, bring the, so because if you do minus e to the power minus x and then you differentiate that, then it ends up e to the power minus x, e to the power minus x. But if you obviously integrate that, it goes back, then it's going to be minus e to the power minus x. So now what you can do is uv plus integration of v du. It will just lead to um, sorry, making a mistake, right? Why am I writing y? It should be the left part will be y e to the power minus x. The left part doesn't change actually. Sorry, I was doing the right part by accident. So y e to the power minus x, this stays as y e to the power minus x. But this one will be the, obviously u is equal to So u is a god. So u is equal to x, du is equal to dx, and then obviously e to the power minus x, you can hold that as dv. dv is equal to e to the power minus x, v is equal to e to the minus e to the power minus x. So therefore uv minus integration of v du, which then ends up as minus x e to the power minus x minus e to the power minus x, right? So now I'm going to combine the left, I'm going to combine the right. So step 6, combine the left and right equations. I'm going to have y e to the power minus x is equal to minus x e to the power minus x minus e to the power minus x. Now this is where we are going to add this plus c, because at the end of the day we have a constant, right? At the end of the day we have a line. So this is where we're going to add plus c. Sure, you can do the cutting and all that stuff. You can cut out the e to the power minus x and all that stuff, right? So you're going to have y is equal to minus x minus 1 plus c e to the power x. Yeah, you can do that. You can do that. And now if we add the initial condition, x is 0, y is 1. So 1 is equal to 0 minus 1 plus c e to the power 0, which is 1. So now you know your c value, 1 minus 1, which is, sorry, no, not 1 minus 1, 1 plus 1, which is equal to 2. So then therefore you're going to have y is equal to minus x minus 1 plus 2e to the power x, right? So the main thing that we did was first look at the equation, look at your differential equation. So the first main thing that we did was look at your equation. You look at your equation, so dy by dx is y plus x, and then you're going to make sure that you're going to make that dy by dx is equal to y plus x into an x equation. So x will be, or dy by dx minus y is equal to x, because you're going to get an integrating, your integrating factor actually sleeps in that y. So when you do dy by dx minus y, you eventually get a value. We'll do another example, yes. So dy by dx minus y is equal to x. So you know that the minus 1 is the integrating factor. And then you're going to do e to the power e to the power whatever the value you get for y dx, and then you integrate that. And then you're going to use that as an integrating factor, multiply that entire original equation, that original modified equation, which is dy by dx minus y is equal to x. You're going to multiply the entire thing by the integrating factor, and then you're going to make sure that when you solve the equation, you will automatically come up with the solution that, oh, okay, this is a differential equation, or this is some equation that correlates, a differential equation. And then you're going to do the solving, you're going to make sure that you get the general equation. So here like e to the power minus x dy by dx minus e to the power minus xy, you easily figure out that, okay, so this is the differentiation of y e to the power minus x, right? And then you're going to integrate that the left hand side, then you're going to integrate the right hand side too, because this also has a dx in it. So you're going to integrate both sides, and then you get the equation for the integrate the left hand side, integrate the right hand side, and then you're going to get c, because obviously it's a constant. You need to get a constant value, and obviously you have x equals 0, y equals 1, substitute them, swap them, all that stuff, and then you get a constant value. Cool. Let us do another question. Let us do another question. This time it will be a little tricky. Master example 2. Now we're going to say dy by dx is equal to y square, y of 0 is equal to 1. So dy by dx is equal to y square, and y of 0 is equal to 1. You don't have an y square plus x here. Because if you had that, then you're going to write dy by dx minus y square is equal to x. But now you don't have an x. You have nothing. You only have y square. What would you do? Sorry. There is something called separation variables. So you can separate the variables, meaning you can separate the y and x. So unlike here, where you can do dy by dx minus y is equal to x, then you may have that perception that dy, then we can write dy minus, so if I write dy by, sorry, if I write dy by dx minus y is equal to x, then you're going to multiply the entire thing by dx. So you're going to write dx minus, so no, not dx, dy minus y dx is equal to x dx. But why do you want to write y dx, right? Why do you want to write y dx? Because even if you try to integrate that, sure, you can integrate it. Who said you can't? You can, but it still remains as y. And then even if you try to integrate the dy here, then you're going to have y minus y, which then ends up as 0, but you don't want to have 0. So the best thing you can do is you can do dy by dx minus y is equal to x. Pretty simple. And then x dx, you can, you can integrate that, but then you end up as what? Half x square. But again, you're trying to get an equation here, right? You're trying to, because, okay, y of 0 is equal to 1. You can write x is equal to 0, y is equal to 1. That's completely fine. But you must make sure that it doesn't only meet for x is equal to 0, y is equal to 1, but it also meets for all the other values. You already have an x. It's very easy for you to get an integrating factor. Your main first step is to make sure that something equates to x. That's your first step. So step one, you must make sure that you end up as some equation is equal to x. Always. You have to always make sure that some, like, whether you do the separation of variables, whether you do integration, whether you do any multiplication or whatever, you must make sure that whatever you do, your first step should be the one, some random equation is equal to x, and on the x equation that integrating factor sleeps in it, like exist, as in exist. So now here the difference is that we don't have an x here. So it's not easy, right? We don't we don't have an x here, which actually doesn't make it easy to solve it. So what we're going to do is separate the variable. Separate the variables. So I'm going to have dy by y square is equal to dx. So I'm going to move the y terms on one hand. I'm going to move the dx terms on the other hand. Now, obviously, this ends up as y by 1 by y squared dy is equal to dx, so which is y to the power minus 2. I'm going to now integrate that. So y to the power minus 2 dy is equal to integration of dx, which is minus y to the power minus 1 is equal to x plus c. Right? Pretty simple. Now you have an equation, right? Here, you already got your equation. So technically, you already got your equation. It wasn't necessary to go through all the harsh steps because you got your equation. So now what you do is minus 1 by y is equal to x plus c. Sure, you can do that. So 1 by y is equal to minus of x plus c, which then ends up as minus x minus c. Now x is 0, y is equal to 1. Oh god. Sorry. So if 1 by y is equal to minus x minus c, then obviously I can multiply this If 1 by y is equal to minus x minus c, he's going to switch y is equal to 1 by minus x minus c, right? Right? Now you can do all your calculation. You can also do one more thing. So you can like consider that C1 is equal to minus C, because obviously you have minus C, but you want to make the constant or whatever the equation you have as a clean format, right? So let's say your minus C, so it's optional, but it makes it much more neater. So a neat step. So I'm going to say C1 is equal to minus C. Then I'm going to say therefore y is equal to 1 by minus x plus C, or y is equal to 1 by C1 minus x. And x is 0, y is 1. So x is equal to 0. Then I'm going to have C1. So 1 is equal to 1 by C1. C1 is equal to 1. So technically, your minus C is equal to 1. Right? Cool. So that marks the end of initial value problem, section 1.2. I would highly suggest to maybe few more questions. Maybe I have stated which book to use. There are a few questions that exist on the book. You can try them. And yeah, if you have any questions, make sure. I'll try my best to collect more questions, maybe hopefully set them as PDF format. And if you want the book, I'm going to set few images. You can do them, understand them. You can use ChatGPT or whatever, you can use it. And then, try to learn, understand what's going on. Cool.